Good morning, students. Today we are going to see the topic starting of single phase induction motor. So already we know that introduction, construction, and working principle, and next one the starting method. So it is classified based on that starting method. So that so what are the types of method available in single phase induction motor? And before going to see the basic points about single phase induction motor, auxiliary winding is provided and motor starts as a two phase motor. Actually, the single phase induction motor have two winding. One is main winding, second one is auxiliary winding. Both winding are placed at 90-degree phase shift. So the main winding is a starting coil, auxiliary winding is a running coil. So that it is displaced 90-degree phase shift, and when the motor speed about 75% of synchronous speed, the auxiliary winding is disconnected from the circuit by centrifugal switch. So in that two winding, at a time of starting, the both winding included after starting the motor, to achieve 75% of speed, the auxiliary winding will disconnected by using centrifugal switch. And after disconnected the auxiliary winding, only the main supply is going to only main winding. So it is a main winding, and it is auxiliary winding. It is 90-degree phase shift, and this is the squirrel cage rotor. And types of winding. The auxiliary winding has high resistance and low reactance. Main winding has low resistance and high reactance. So in that way, they are designed. So speed torque characteristics of single phase induction motor shows after 75% of rated speed, only the main winding is present in the circuit. So then, classification of single phase induction motors, split phase motors, capacitor start motor, capacitor run motor, capacitor start run motors, shaded pole motors. So these are all classification of single phase induction motor. So let us see one by one. The first one is split phase motor. So this is the circuit diagram for split phase motors, and the two winding, main winding, auxiliary winding. This is a squirrel cage rotor, and this is for resistance, and this is for centrifugal switch. Low resistance, high resistance means the main winding resistance and auxiliary winding resistance. And input supply is single phase across phase neutral. So the given supply of across phase neutral, at the time of starting you can include that both winding, main winding and auxiliary winding. So after 75% reach the speed, by using this centrifugal switch, cut this auxiliary winding supply, and the rotor will rotate by the supply of only main winding. So this is the output graph phasor diagram. So with respect to voltage, the current will be lagging. The current, this is a total current. I is a total current. Is a starting coil current. IR is a running coil current. So at the time of starting, you can include that both current. It is a total current I. So I equal to Is plus IR. So this is the output graph for split phase motors, and main winding and auxiliary winding. Main winding and auxiliary winding at the time of starting, we can the graph is high starting torque. So after 75%, after 75%, after 75%, it will come down by excluding the auxiliary winding supply at the time of centrifugal switch operations, and it is only for main winding supply. So that starting torque is will slightly reduced at time of disconnect the auxiliary winding. So characteristics of this motor are: starting torque is 100 to 250 percentage of rated value. Breakdown torque is up to 300 of rated value. Power factor of this motor 0.5 to 0.65. Efficiency of motor is 55 to 65 percentage. The power rating of this motor, the range of zero point 0.5 to 1 HP, because it is a fractional kilowatt machine, so that a zero point 0.5 to 1 HP. So applications are fans, blowers, centrifugal pumps, washing machines. This is the first type of single phase induction motor, and second type, capacitor start single phase induction motor. So in the type of induction motor, here included capacitor, because here the input supply the same main winding, auxiliary winding, centrifugal switch, but here one capacitor added in series with the auxiliary winding. But in previous type of method, there is no capacitor, so that here capacitor included, so that it is capacitor start single phase induction motor. So what is the difference of previous method and this method? So the same operation will apply here. So the given input supply single phase, at the time of starting include main winding, auxiliary winding. The rotor will rotate it by including of capacitor. So that here include the capacitor, the torque will be more high. Starting torque will be more high as previous method. Main winding and auxiliary winding including capacitor supply, so that at the time of starting it will reach maximum starting torque, and reach 75 percentage of speed. By using centrifugal switch it operate, and it is reduced to main winding only, so that it has graph only for main winding, so that it is included that centrifugal switch. So this is the difference between the previous case and in this method. Here the phased diagram with respect to voltage, the current will lagging, but here added with the starting current and running current, both added with the total current. Thank you. So the remaining method we will see next class. Thank you.